All right. Thanks, Abel, and thanks, Lisa, for organizing this Data Science Day. It's a very exciting event. My name is Yang, and the next 10 minutes, I'm going to tell you what is fairness issues in algorithm, and in particular, what is this issue in machine learning. Right. So we love machine learning. Machine learning is becoming increasingly popular. That's part of the reason we're here. It's almost used in many daily applications of our life. Right? We enjoy the performance of machine learning. We enjoy it's like 80% accuracy, it's 90% accuracy, or even higher. But for the other 10% times, we had an error. Right? We had a wrong recommendation of food. We had a wrong recommendation of a movie. It was annoying, but we were fine for most of the time. However, if you think about it a second time, when you're applying machine learning to other high-stake societal applications, in this example, people are applying classification to do automatic bill decision making. Right? A single error can change a people's life entirely. Okay, so we want to be careful about the errors. But you may argue, well, humans make errors too. We make mistakes. So it's not entirely reasonable to blame on machine learning for making mistakes. That's very much true. But this talk, I'm gonna raise awareness of this issue of fairness. When we are making errors, we want to make sure everybody is treated fairly, such that machine learning is not going to reinforce the bias, or it's not going to introduce a bias to our society. Okay. So why machine learning is unfair? Right? So early in the time, people had this perception machine learning is fair. And I think there was a really good argument. I'm showing you the very simple pipeline of a machine learning system, how we train machine learning for data science applications. We have the data being collected. I denote them as xi, yi. So xi is the features, like the profile of the data. The yi is a label telling you what's going on with this data. And often with this data, you can think of their DI. These are the sensitive attributes. They tells you the gender, like race. These are sensitive attributes we want to protect for this customer or for this customer's data. This data will be fed into training. So if you know machine learning, you're gonna notice this is a very simple training procedure. You minimize some like loss functions, sum over the entire database, right? Telling you how well this model is doing on fitting this data. And then you deploy, you get your decisions. This looks really fair because it's pretty objective. There's no human intervention. It looks to satisfy procedural justice because everybody is treated with the same data, same training, and the same decision-making classifier, right? This was a perception, but the next 10 minutes, I'm gonna tell you this is not really the case, right? First of all, the data, X and this, they're often noisy. I've been talking with my collaborators at Harvard Medical School. When they are making treatment decisions, they got all the measurements from their equipments, but the equipments are very noisy. It has noisy data. They can be really biased. And the sensitive attributes are often not clear. People can choose to misreport or even not report their private information. And often you can only infer from some third-party data. And what makes things even worse is this data can often encode historical bias, right? When the data is collected from activities, from human activities, it means it naturally encodes whatever bias that is already existing in the society, right? And if you're generalizing over this data, you're only going to generalize this bias in this data, right? But even if the data is clean, I trust my data is cleaned and very well taken care of, does machine learning do a good job there? I have multiple reasons, but I'm gonna tell you two. But the first one, the machine learning that is going to suffer from is the tyranny majority, right? So when you're doing optimization over the entire database, do you really care about the minority group of this database, right? The answer is really no, because the derivation is very simple. You write the summation of the loss functions as two partial sums, one over group A, another over group B. But think about the case group B is only 5% of the population. Right. Now you're optimizing the entire sum. How much effects will group B give you? It's gonna be very marginal. And Amazon noticed this already. So Amazon was pretty excited about creating a recruiting tool to automatically detect how well this applicant is going to succeed in their company. So this is like resume screening tool. But sooner they realized this tool, even though the claim has a really high accuracy, is biasing against a woman. This is exactly because of the tyranny majority, because in their database, the female group represents a much smaller group. And when you're training the classifier with minimizing the errors, it simply goes oblivious with the female group. Okay. The second concern I want to raise is the power of machine learning. If the model is not really regulated, the power of machine learning can be misused. Right? We know machine learning is really powerful in terms of detecting correlations. Right? We don't know how to reason about this data. So we use machine learning. It undercover this correlation between all the variables. But this power can be very much misused. Right? This is a question I often get. Right? So is this fairness issue simply require the sensitive attributes like gender, race, age, whatever to be removed from the data set? Can you not just do this? I think the answer is even if it did, it does not work. Right? This is example again I took from Amazon. This is a same-day delivery service offered by Amazon at the Boston area. I think according to the law, it's illegal to use sensitive and private information to decide on this service. So Amazon was very aware. They remove all the private information. But then you're going to realize there's a strong correlation between zip code and the majority race of the community. Right? And the machine learning algorithm is simply smart enough to understand this correlation. And then this zip code is when the zip code remains to be part of the feature, it preserves this discrimination or bias against a certain group. You can see this is like same-day delivery service has a strong correlation with the zip code and further with the race. Okay, I can keep going down the list forever, but this last point I'm gonna mention. Often machine learning decision makers is very different from human decision makers. They are often lacks explanation and recourse. Right? There's another example I gave where there are many financial applications or financial services. They're actually using our data to make decisions, to make the loan application decisions or credit card application decisions. Right? Imagine my credit card application is denied. Right? Bummer. I think legally I require an explanation and I require a recourse. Right? Well, many times machine learning methods do not give you explanation, but that is relatively easier to do. Because if people realize this, they're going to tell you, OK, this is my decision boundary. You're here. Do this. Cross the decision boundary. That's doable. But the more serious issue is like machine learning doesn't know what actions or what recourse is actually actionable. Right? I don't want to hear this explanation like, you're denied, but try to reduce your age. Right? That's not actionable. Or your degree is part of the feature. You have a PhD. How about you remove it? Right? This is not really doable. Right? We want to make sure machine learning can take care of these societal constraints, like these human concerns. But without human intervention, this is simply not doable. All right, there have been many algorithmic responses. The first one, for example, is very natural. Can we translate these societal constraints into mathematical forms or statistical notions and add these constraints into an optimization question, try to solve it? It works for many cases. And also part of our works have been looking at this literature of social choice theory. So we've been trying to borrow or interpret the preference-based social choice theory into machine learning to make individual decision makers for different people so people prefer their own decisions. And recently, I think it's going to be a very interesting topic. People start to use causal modeling to understand what is going on, what is really affecting the decisions. That gives people more explanation. All right, so I think this is a really quick talk. I want to stop here. My takeaway is like this area is by nature is more like a social and ethical concept rather than a statistical concept, and it requires interdisciplinary collaborations across different areas. Without care, algorithms, even they can automate many of the decision-making procedure, it will be a mirror of the current society, and the data is only reflect the present and history. So we don't want this to be a reinforced mechanism of this existing bias. We really think this as a pipeline again. We really require a good component at each part of this pipeline. We want good data, good algorithm, and also when it's come back to human, when the decision comes back, we want a robust discussion of the social norms. Right? Okay, this concludes my talk, so I welcome questions during the panel.